Okay, so today we're going to talk about some more features that we can add to our classes for our objects. And right now we do things in our program like this. So this is my animal class. I'm just going to write some code in here. How do I compare, say, my A is a variable that has Dave in it, and my B is a variable that has Dave in it. How do I compare if A and B are the same variable? All right, if A equal B, is it equivalent to B? All right, then I can say puts yay, something like that. So let's run this. And it's true. A equals B. So what type of object is A? Very good, string. And B is a string. So this, in fact, is a method in Ruby. Equal is a method. It's defined as a method in Ruby. So I can override how this method works. I can change the properties of the equivalency command. All right? So, so if I have a new, let's create a couple of zebras here. If I have a zebra dot new, and I give it the name Dave, and he's gray, and he's got 300 stripes, and I do the same thing for B, are these two objects the same? Why? They're different objects, right? This guy, even though he has the same properties, it's a different, completely separate animal that came off the assembly line. I've got an A animal and a B animal. They came off separately. So they are completely different, so I get nothing. They are not the same. Maybe I should put that. Else puts, yeah, boo. There you go. So I get a boo. They're not the same. But what if I want to compare that these animals are the same? How could I compare these different zebras? Well, I typically don't name my zebras the same in my zoo, right? So if they have the same name, I might consider them to be the same object. Okay, essentially the same object. So instead of A to equal B, I could say what? How could I compare their name only then? All right, I could say A dot name. Is that equivalent to B dot name? So is that maybe? Yay, they're the same, okay? Because at this point, first of all, what is the object A? What class does it come from? Zebra, okay, directly from zebra, inheritably from the animal. What is this then? What class does that? A string, okay, because the name value, the name attribute of my zebra object is a string, right? So I could do this with anything. I could compare their stripes. And is that going to be the same? Potentially, right? Yay, they're the same. Because now what is this class coming from? Integer, or the fixed num. And this is a fixed num, so it can compare two fixed nums together. I can't say, is A equal to name? What's that going to do? Boo, I can't compare those. Those don't have any comparison. All right, but I want to be able to let my user of my class, remember we're writing classes for other developers. We're not writing them for the end user. We're writing them for the developer. So I want my developer to be able to do this. And if certain attributes are the same, I want to say they're the same. It's the same object, okay? So I want that to come out to be yay. So how do I do that? Rewrite the method. Okay, I can rewrite the equal method. Right? This is just cool. In my animal class, I can compare and add a new method, just like we did a 2S. Did I do a 2S? I didn't do a 2S. I didn't do a 2S? What the heck? I almost do a 2S. Let's define a 2S just for fun. What is my 2S going to be? Maybe he's going to print out, he's going to return a string that looks like his name and his color, because that's all I know about in my animal class, right? All right, so now I have a 2S. So just like I can override the 2S method, which is a built-in method in Ruby, I can override the equal method. So to do that, just like we did the 2S, the equal method is called equal. Isn't that surprising? And the parameter that I'm passing to it is the right-hand side of the equation. Because the left-hand side is what? It's the object that I'm calling the equal on. So that's myself, the self attribute of this, or the this, if you're thinking in JavaScript or C#. So just like in the 2S, what is that applied to? It's applied to the stuff before the period, before the 2S method, right? Dave.2S. The Dave object is what I'm working on here. So that's the values that I get. The other is the right-hand side of the equation. So in this case, this actually looks like this. All right. This is on the A object. I want to call, using the dot notation, I want to call the double equal method, and I want to pass it a variable of the right-hand side. But in shorthand, we don't use the dot and all this. And in fact, I don't remember ever when yeah, it does actually work. Okay, so this is the longhand version of writing the equal sign. So that is the same as if I do this. All right, just to have that as a reference. So the A part is to the left, so I'm going to call the equal sign on the A object. So that means I'm going to look up the A chain, and A is what? What type of object is A? A zebra. Okay, so I look in my zebra class. Do I have an equal method in here? Not in my zebra class. So I say, oh, well, he came from the animal class. So let's look up again the chain, and I look up for my animal class, and here you go. I have an animal method that is defined the equal method. If I didn't have this, it's going to go up the chain again and eventually end up at the object method, the object class way at the top, and that has an equal assigned to it, and it compares if the object is truly the same object. It's got the same ID, it's the same position in memory, and everything like that. So for this, we need to return, what kind of a statement is this? What do I call that type of statement? A Boolean expression, right? Boolean statement. So that means that this method, the equal method, has to return what? A true or false, right? So I can do anything in that method as long as the end result is such that it is a Boolean expression. So I can do something like is self refers to what? Now, the zebra that's on the left-hand side of the equal, right? And I can say, is that equal, let's check its name, is that equal to other dot name? Okay, so let's see what's happening. Let's see if that works first. So I've got my Dave. They have the same name, so this should put yay. Yay! I got it right. All right. So let's see what's happening though. Why did I use the equal equal? Doesn't that call itself up here again? No. Why not? Well, what am I comparing here? What is this? What type of class is it now? Well, the self is just the zebra. Okay, what is self.name? That's a string. So I'm comparing a string versus a string. So this is the same thing as if I write it in the weird notation, self.name dot equal other dot name. All right, so let's see what does that do. The period before the equal sign refers to this entire object, which is a string class. So it's going to call the string class's equal method, not my animal class, because it depends on what I'm comparing. That's the whole point. I can add like objects. I can compare like objects. So that's why that's not a conflict. It depends on what specifically we're looking at here. And I drilled down one, and I made it so that the names are equal. Okay? Any questions on that? Does that blow your mind yet? Killing you. Good. All right. So maybe I want to make sure that not only is their name the same, but I want to compare that their color is the same as well. All right. So how can I make my Boolean expression more specific? All right, and, right? So I want to compare that, and I want to compare the self.color with what? Other.color. All right, so if this is true and this is true, then I'm going to consider that my animals are the same animal for the case of this. Okay, so this should still be yay. Yay! Isn't that cool? Has everybody got that so far? Isn't that weird? That's a weird concept. But this allows you to compare records, if you think of it in databases. One record from one table, is it the same as another record in another table? Well, I have to define what does equality mean in terms of a massive structure of records. I might want to compare everything in it except the ID, perhaps, right? The ID in two different tables might be different, but the data that it contains is equivalent. So I might want to change the way my equivalency method works to make my programming more elegant. This just makes it's an elegant feature to allow this equal.
Does that just use programming?
Yes. Yes, it does. What was your question, Brendan? Or your statement? You're just snoring through my class. All right. So let's blow your mind again a little bit. Since I can override the equal method, I can also override the plus method. All right? What does plus really do? Well, if I were to write the plus method in Ruby, in the non-shorthand way, it would be a dot plus b. All right? So the plus is actually a method that's called on whatever class the A is. So if the A is a zebra, it's going to call the plus method on the zebra class. And this is going to be the other part of that. So let's just see if I can do that. And it says, wait, I don't know what plus means for Dave Gray Zebra, right? It doesn't make sense to me. I don't know what to do to add two objects together like that. But in genealogy, let's think, what would I do? What's an easy way that I can combine two zebras together? It's crazy. Yeah, we need some nice music going on, right? So you guys are terrible. So let's say that I want to combine these together. So this is my wife, Karen, all right? And I'm going to add A and B together, and I get a new offspring, which would be a new zebra that would have some different attributes. So that might be the reason I'm going to have this plus method. So let's go to my animal class, and I can define this plus method. And the plus method, I want it to actually create a new animal. And I want it to have different attributes. So I need to call, I want to return what type of an object? An animal object, right? I'm going to create, I'm playing God here a little bit. I'm going to create a new animal. So I'm going to say animal.new. And what attributes do I have in an animal case? Name and color. So their name is going to be, just to make it programmatic, I'm going to combine their names. So the new guy's name is going to be Dave Karen, or Dave-Karen, whatever you want to do. So how do I get the first object's name? Self.name. And I want to add it. Maybe I'll put a dash in between it, just for fun. And I want to add it to the other .name. All right, so that becomes the name attribute of my new animal. And then my color is going to be maybe the same thing. I'm going to have, I'll do it this way just to be different, self.color and other.color. So that will create a new animal with two new attributes, and it's going to return that as a result of that, because it's going to be a child, right? It's going to be a new animal. Just like if I did this, now if I did Dave plus Karen, and I put that in a new variable, what this is doing is it's calling the plus method. This is just like doing this, Dave.plus other. All right? So it's calling the plus method on the string class, and it's adding two together, and it's in fact returning you a new string, right? It created a new object that has these two properties combined together. So if I were to put out A here, I get Dave Karen, right? So that's in a string case. But if I want to combine my two objects, I want to have my C, or my C object is going to be my A plus B. So what type of object is A? Zebra, and I'm going to call the zebra's plus method and add it to another zebra. Okay, so I look up, does my zebra class have a plus method in it? No, so it goes to its parent, and it says, okay, what am I going to do for a plus? Well, I'm going to create a new animal, and I'm going to combine their names and their color together. So C is now what type of an object? No, he's actually an animal. He's not a zebra. That's a different problem. But he's an animal. So let's say puts. You get a mutant, right? I could add a hyena and a stork together and get whatever, right? So this is my new object, my C. He's a Dave Karen is his name, and he's gray, because I added the grays together, right? He's a gray. Isn't that cool? That's just really neat stuff.
Well, I guess it's confirmed that it's gray.
He's definitely gray. He's not going anywhere else. So you could do all kinds of genetic fun stuff with that. Does that blow your mind? Ruby is amazing what you can do with that, and this is used a lot in programming to make it easier. I can manipulate these higher class objects. Yeah. In Ruby. They do that in other languages as well. Java lets you do this. You can override some methods. I doubt that C# does. A lot of other languages let you override these types of things, and they're used quite a bit. So, any questions on that so far? Let that one sit for a minute. All right. I wanted to get into one more thing. Obviously, I could override the multiplication method and the division method. They're just methods in Ruby. So I can change behavior, make my new class that I create, my new object, have these different properties. So since this is so common, especially in terms of comparing different objects together, I want to compare equality. I want to compare if one animal is less than another animal, I would have to figure out what that meant. Maybe he has less number of stripes or something like that. And I could compare if they're greater than or equal to, all kinds of different things that become very useful. Now, it starts to break down in my animal class, but I can add some functionality by including a pre-written piece of code called comparable. There's a module called comparable. This is Ruby code that was written just for this case that creates all of these less than, greater than, equal, not equal to methods, all the equality type comparing one object to another, and it creates methods for those. Okay? The only thing I have to do then, instead of declaring this equal method, I have to declare a method called the Spaceship Operator. And that is actually an operator in Ruby, and I haven't seen that in any other language that I can think of. So what this means, they call it the Spaceship Operator because it looks like a little flying saucer, right? A spaceship operator. But what it is, it's a method that returns 3 different values. If it's less than, it returns a negative value. If it's equal, it returns 0. If it's greater than, it returns a 1. So I get a 0, a negative 1, a 0, or a 1. That's all it is. But I don't really care about that. I'm just gonna change this to look at specific attributes in my object here. So I'm going to change this, and I want to use the comparable operator here. Too many equal signs. And I'm going to compare whether their name is comparable to the other person's name. So what this is going to do is going to return a 0, a negative 1, or a 1, this operator. If this left-hand side is less than the right-hand side, it's going to return a negative value. If they're equivalent, it's going to return a 0. If it's positive, it's going to return, if the left-hand side is greater than the right-hand side, it's going to return a positive value. So we don't really have to care what the value is that's returned here. All I have to do to use this comparable, they call this a mix-in. I'm mixing in some code that somebody else wrote, and I have to override this one method, and that one method will give me all of the comparables. I can compare now one animal. Is it less than another animal? Is it equal to another animal? Is it greater than another animal? Is it not equal to another animal? All of those comparison operators are combined into this one operator. It overrides all of those. There's like 10 different methods that it will override. Yep. No, you can use it otherwise, but it's not very useful otherwise, because it's just not very useful. let's just show you. Let's say puts Dave compared to Karen. All right, let's see what that does. I get a -1 back, okay, because D is less than K in the alphabet, right? If I put Z Dave, is that compared to Karen? What is it going to bring?
1.
Well, I get a +1.
And so if you put
And if it was Karen and Karen, I'm going to get a 0. So based on the return of that, I'd have to set some variable equals that, and then I'd have to say something like if A equals 0, then they're equivalent. You know, I just wouldn't write code like that. It's too verbose, right? It's just not very useful in that case. So that's how it's used. It's just not useful. But in the comparable, that comparable writes all of these other methods for me, like the equal. It writes a less than or equal to. So now that I have two different variables, two different zebras here, I can say puts A less than B. I can say puts A greater than B. Puts A equal B. Puts A greater than or equal to B. Puts A not equal to B. I get all of these methods. Remember that these operators are just methods in Ruby. I get all of those for free by overriding that one spaceship operator. So the first one, A less than B, is Dave less than Karen, because in my overriding of the method, I'm comparing only the names, right? So Dave is less than Karen, that's true. Is Dave greater than Karen? No. Is Dave equivalent to Karen? No, because we're using the strings here. Is Dave greater than or equal to Karen? No. Is A not equal to B? Is Dave not equal to Karen? That's true. So I get all of these cool little methods. Pardon me? Yeah, because Dave is less than Karen. That works. See, that's just good.
Well, it kind of works because you're married.
Exactly. It's a good thing. All right, any questions on that? I get additional methods like if I had an array of these things, I could use an array dot. If I had an array like my cage equals an array of A and B, I can say puts cage dot max, and it searches through the array, comparing each one using my comparing operator. And in this case, it's comparing the names. It finds the greatest name in this array for all of my animal objects that are in the array. And I came back with the Karen Gray object. I can do the min. What do you think min is going to give me? Dave, right? So I get the Dave object back. So there are other methods that I can utilize on the array class that utilize this comparable operator that make your programming just really clean and nice when you're dealing with complex objects like that. All right, any questions? I'll have to let that sink in for a while.